Hello guys, my name is Michael. We are going to move on with our GTKSpinButton widget, and let's take a short break from the last tutorials. As you already know, we are talking about functions. We saw what these functions are, how we can use them, and so on. Also, next thing we were talking about properties. We saw that we can use a property which belongs to this spin button, and also we saw that we can apply some properties which are not belong to the spin button, but spin button instead read from a GTK entry, and so we did use its properties, which works fine on spin button because inner hits. The spin button widget inner hits properties and function from GTK entry, and also we know that it belongs to, it is a subclass of GTK widget. So this means we are using opacity and margin top and margin bottom as example properties, which doesn't belong to this spin button but to the widget itself, GTK widget itself. So basically we know how we apply these properties. Okay, now the next thing what we are going to do today, it is signals. We are going to talk about signals. We are going to see how signal works on this spin button, which kind of signals are available for us, for the programmer, and for our applications. And that being said, let's see. Here's our last program. I'm going to drop these properties now because we don't need them right now. So I'm just going to clean a little bit this program here. Okay. So that being said, we have. I'm going to move the adjustment up here. So now we have the adjustment, and then it will be passed to our spin button, and everything should be now fine. Let me compile and run it and see. Yes, works fine. I'm going only to let the object set spin button, and I need the margin top top 100, and of course the margin bottom also 100, and of course we are informing our GObjectSet function that we are done by passing null at its last parameter. So let's see. Works fine. Okay, looks good. So now we can work with our GTKSpinButton. So that being said, let's see. We are going to talk about signals. The signals are there to can be used. So let's see the first signal here, change value, and says the change value signal, it is a k-binding signal. Okay, so which gets emitted when the user inits a value change. Okay, application should not connect to it, but may emit the G signal emit by name if they need to control the cursor programmatically. The default binding of this signal are up, down, page up, and page down. So basically we are not going to use this signal because as here already said, application should not connect to it. But what we can do something else. We can GTK adjustment, because we are working with adjustment. We can take the change value, the changed signal from the adjustment. We can apply it for our example. So this means basically we are going to create a function. Let's catch the signal first. So G signal connect, here is the function, swap it. Okay, here is our function. We are going to catch the first adjustment, the first adjustment. Okay, the second one, it will be the changed. The next one will be our callback function, which is the adjustment callback. And the last one, of course, is the adjustment itself again, because we are swapping. We are not going to use more than one parameter, so the gsignal connect is not needed. Now we can create our function, which we can use it. Okay, so that being said, now we are going to GTK adjustment, create an adjustment pointer here as parameter to this function. Now that we have it, we are going to set gprint the adjustment values was changed, for example. Yeah, I think you're already familiar with this. I'm going to cast for a moment. Now, what did we did here? We were basically catching the changed signal of the adjustment on the adjustment itself, and then we are calling the adjustment callback, and we are passing the adjustment also as its parameter. Let us compile and run the program, see what happens. And basically here you don't see nothing because we didn't change some values. Now we can let me copy this one here. Now I'm going to make some changes here. So I'm going to say upper, it should be now 150. So basically we change it to 150. Okay, now because this change happens, we said okay, GObjectSet is invalid object class, GTK has no property upper. Okay, where? Of course, because we need the adjustment. So let us catch the signal before. You know what happens? Let me show you. If you catch the signal after you set the property, nothing happens more than a segmentation fault, and this also happens, you know already why, because we need to pass a double and not an integer. Okay, I fix it, and now I compile the program. As you can see, we see nothing here, and that happens because we made those changes before we catch the signal. But remember, always catch the signal. It is a good thing for you to know, always catch the signals after you create your widget, and then when you made those changes, the signal which you try to catch is already marked. So now watch, says the adjustment value was changed, you see. Now of course, if you change the lower to, I don't know, let's say 10, because now it's 0, you get again the adjustment values was changed. But which kind of adjustment? I mean, basically this let's say change it max only, let me see, only what say emit when one or more of the GTK adjustment value have been changed other than the value properties. Okay, so this says adjustment, the object which receives the signal and the user data set Okay, flex, no recursion. Okay, so how would you catch this kind of signal? I mean, maybe I need to know how to catch this change of signal in a manner that I know which kind of value was changed. I mean, was the lower, was the upper, was the page increment, page size, was tab increment, which one? We know that was something changed, but we didn't know why. Okay, well, one way will be, I don't know, let us create a structure, call it values, okay, and then here let us create some G double value. Oh no, value it is, yeah, it is not important now for us. Okay, okay, value, lower, upper, let's say step increment, page increment, and also page size. Okay, now we are creating these values, isn't it? Yes, we did. Now, because we have these values, which we create them, let's create us also a global one. Okay, we have a value here. Now let's create a function and let's call it void let's say set up values. Okay, so basically these values will be set the way how we want to. So this means this value we are going to create them like this. One, okay, again G double value, lower, upper, let me copy this. Right. Let me copy it because it goes much faster. Page increment and page size. Now let us create a function which basically sets our values to some desired values, and let's say values lower, it should be set to lower, isn't it? Yes, lower. We are going to talk in a moment about this. 2, 3, 4, 5 and value also, yes. Okay, so the first one is the value, the second is the lower, and the next one is the upper, step increment, page increment, and the page size. So we created now a function. This function set up our values to some desired values. Now watch, we are going to call this function before the adjustment here, and we are going to pass these values here. Okay, now that we have these values, we are going to make some changes here. Values, value, this is the first one, the second one, third one, fourth one, fifth one, and sixth one. Okay, now the first one is the value, the second one is the lower, upper, step increment, page increment, and of course the page size. Now what kind of changes did we make here? We were setting the values of our structure, this one, by calling the setup values and putting these values inside. Okay, value, I forgot to upper, step increment, page increment, and also page size. Okay, now let us indent our code so that's better be read. Okay, now and then we are setting the values here. So basically our adjustment values now are holded into our structure. Okay, let's compile it on the program now and see what happens. And as you can see, the adjustment value was changed. Okay, so we know because it works because we didn't we did set these changes here. Now let's let us make some changes. Okay, so this means we are going now. Let me move this function down here because we don't need it anymore. And now let us make some changes to our adjustment, which will look like this. We are going to create some variable G double call it temp lower. This is 1 2 3 4 5 temp. I want temp lower. Okay, the next one which I wanted, it is, so looks like this in a moment. Now temp lower, temp upper, temp step increment, temp page increment, and also the page temp page size. Okay, so these are all temporary. Okay, now let us point them to our getter functions. So basically we are going to set GTK adjustment get lower adjustment. The next one, let me call because it's too much to write, and then I will explain in a moment. Lower, upper, step, page increment, and of course the page size. Now until now, what do we know? We create some temporary variables, and here we are going to put values from lower, upper, step, page increment, and page size inside these variables. Now that we have this variable, we can do something crazy. Let's make some comparison between values lower. So we'll say if value lower is not equal to temp lower, then let's say G print, we should print something. Let's say the value, or no, the lower value was changed from, and let's put two of them here, okay, from values lower to temp lower. It should work. Let me copy this part here, let me draw it here. Okay, now lower. Now that we have this, we can update our structure. Values lower, it is now equal to temp lower. Now let's see if it works. We said, okay, we cannot compare floating points. Okay, I'm going just to convert now to int, because you know what happens if you try to compare to a floating point. Okay, so basically what did we said here? We said adjustment callback, when it's called, saves all these 5 values inside all these 5 temporary variables, and then we are going, let me comment this part for a second to see if it works. So we are going to save the adjustment get lower value into the temp lower value, and then we compare the value lower, which is the lower inside our structure, which was set to 0, with the actual value which it is here. If those are different, are not equal, this means that the value was changed from the actual value which was set when we are creating the value, the lower value, and the actual value which was currently set. And because this change was made, we are making also in our structure these changes so that we know next time when the next change comes. We had to cast our double values to Gint at this point so that it works. Okay, of course you can do better than this, but this is not the object of our tutorial. Today we are going to talk about adjustment and how we can catch it. That being said, lower, it is now set to 0. It was set before to it was set to 0, and now we try to change to 10. So this means now when we are going to catch this signal, this time we are not going to say one value from the adjustment was changed. We are going to see which exactly value was changed. Let's see if I'm right. Okay, I forgot here semicolon, no problem. And compile it around again, and bam, here says the lower value was changed from 0 to 10, which is fine. That being said, because this thing works, let's continue with our crazy part. So I'm just going to copy this one, else if 1 2 3, else if 4, else if. This means we are going to make some changes. This time we are going to compare against upper, and upper, so that we have all these values. Now the next one is the step increment, which is 1, which is 2, and then temp step increment and temp step increment. Now let's move on to the next one, which is the page increment. So we are going to change also to page increment, temp page increment, and also temp page increment. And the last one, it will be page size, which is temp page size. Same here, temp page size, page size. So the value of page size is not equal with temp page size, then the value page size to page size. Okay, so the next one, if the value page increment, and of course we forgot to change this one too, and the step increment we forgot also to change it, and also the upper. Now let me compile and run and see if it works. Of course it works. And now let's make some completed changes. Upper, we'll say lowest upper, it will go to 150. Step increment goes now to 2. Page increment goes now to 5. Now let 20. And also the page size now changed from 0 to 10. Okay, we are going to let it to 10 this time. Now let's see if I'm right. Let's talk about the program flow a little bit. We were creating a spin button. Once that we created the spin button, we declared a spin button variable, and then we point the spin button to the GTK-SpinButton new. Once that we are pointing to this function, we are passing 3 parameters here. The first one is the adjustment, the second one is the clean rate. Let's change it to 1, and let's put 2 digits here. Now the adjustment, we are we were setting it to through the GTK adjustment new by setting the values which we are having them in this chapter. This value we were setting before we create the adjustment by calling the setup value function, and this function basically copies the value lower, up, and so on in our structure. Okay, once that we have the adjustment and once that the button was created, we were adding the button to our window, and then we are setting some margin top and margin button, and before we make some changes to catch which kind of changes are happening in our adjustment, we are basically trying to catch the changes signal of our adjustment by calling the adjustment callback function, passing the adjustment as a parameter, and this adjustment function which we created here basically calls all these 5 function, get lower, get upper, step, increment, measurement, and save them in some temporary variables. And now we are comparing these temporary variables, which are now, when they are set, if they are the same with the values which were set when we were creating basically our adjustment right here. If they are not, then we are printing that the value was changed. Which kind of value took place? Lower, upper, step, increment value was changed, or the page increment was changed, or the page size was changed. So basically we are checking if one or more or all there was changed. If we made, and basically every time when we make these things and we are printing that something was changed, because the change took place, we are updating our structure with a new value which was set at that moment. So let's see. That being said, we were creating an adjustment with a value of 20, we change it to 10, and then we said that the lower should be 0, we change it the lower to 10. The upper was 100, we change it to 150. The step was 1, we changed it to 2. The page increment was set to 10, we change it to 20, and of course the page size was 0 and we change it to 10. Let's see what happens. I will compile the program and run it, and bam, the lower value was changed from 0 to 10, the upper value was changed from 100 to 150. Step increment. Okay, let's see what happens. Let's see if page step, what did step here we made a problem, we have a problem. So upper, step. Okay, here is the main problem. We need to update it to step increment and not to something wrong here. And then we have page increment, and then we have the temporary page increment, which is fine, and then we have page size, page size, 10 page size. Okay, so now should be everything at its place. So the page size, the page increment, the step increment. So let us run the program again and see what happens. Now everything is fine. As you see, now the lower value was changed from 0 to 10, the upper value was changed from 100 to 150, the step increment value was changed from 1 to 2, the page increment was changed from 10 to 20, and the page size value was changed from 0 to 10. So that being said, our function works fine, so we don't need it. I will copy now and throw it down here. Just use pause and watch again and again my code. I think I provide you enough information about the program's flow and about what I did here and what kind of changes took the program. So basically this means this is the way how you catch which kind of value was changed. Just I'm going to change to only one, so this means we are not going to check against all those. We are going to check only if the step increment was really changed from 2 from 0 no from 1 to 2. So we are setting it to 1, now we are changing to 2, and our program should catch this change. Yes, the step increment value was changed from 1 to 2, which means it works. You see 28, 30, 32, 34, 36 and so on. If you change it to, I don't know, 7, it should say from 1 to 7, 1 to 7 as you can see here. And if I update now, 20, 27, 34, 41, 48, 55 and so on, works fine. Okay, so that being said, this is about the first signal which we are talking today. We are not talking about change signal value, because this value, as you can see, it is a K-bit and said application should not connect to it. But I provide you another thing. I showed you how change signal worked on the adjustment, and as you can see here, you can only check which you can only check if one of those adjustment values or more of them, they were changed. You see, emitted when one or more. But of course, if you want to see which one, then you create an adjustment callback where you make these checks by calling all these functions, which we have them here, like get upper, get step, get page, get lower and so on, page increment and so on. So basically, once that we get this function and compare them against our structure values which we were creating, where we are setting the main values to this structure, and we saw that once that those changes are taking place, then we know exactly which change was made. Okay, so that being said, it is enough for today. In the next tutorial we are going to talk about other signals like value change, rapid input, output and so on. Okay, thank you guys for watching. If you like it, please subscribe, share with your friends and neighbors, and until next time, see you guys.